G'day ladies and gentlemen, it is the Raging Ranga here, and welcome back to our series on differential calculus. So in this section we're going to be looking at varying rates of change. So last section you'll remember we had a look at constant rates of change, where we had nice straight lines, you get the slope of that line and you've got your rate for whatever you're measuring. Bingo bango, you're done. Everyone goes home early. Everyone gets a pay rise. Everyone gets a promotion. Everyone gets Christmas Day off. Well, this is the real world, baby, and you don't always get Christmas off in the real world, and you don't always get straight lines in the real world. In most real world situations, you're going to get a mother hugger like this, where it's got a curve to it. So, how do we get the rates of change for a graph that's constantly changing? Well, before we get into the real nitty-gritty stuff, we're going to show you an approximation method. Now, obviously, if I wanted the average rate of time at this point, let's say right at 4 minutes. So what we have here is the temperature of a glass of water left in the sun over time. So our rate will be degrees Celsius per minute. How much is the temperature increasing each minute? Now, if I want to know the rate of temperature increase, say at 4 minutes, well, no, first of all, it's not that I draw a line across and it's 27 degrees Celsius per minute. That's not how it works. We need the slope of the line at that exact point, and that will tell us the rate of change. Now, what you can do is you could draw a line through that point there, and you could get 2 points around here like that approximately, and get the slope that way. Well, that's a possibility. What we're going to look at is the average rate of change. So the average rate of change between 2 points. So for example, if I wanted to get the average rate of change at 4 minutes, I might consider, rather than the rate of change at 4 minutes, I might consider the average rate of change between, say, 3 minutes and 5 minutes. I get the slope between those 2 points, and that would probably be pretty close. So we're going to work our way up. And that's what this green box is here. Draw this green box down now, and we'll talk you through it. And we're back. You're done drawing? Fantastic. So, the average rate of change, we're talking about the average rate of change here in your function f of x from x equals a to x equals b will be f of b take f of a over b take a. What the heck does all of that mean? Okay, first of all, we have our graph here. We have our graph, our function f of x. If you want to learn about functions, you can watch my previous videos on functions. While you're at it, you can like, subscribe, notification, donate, I don't know, give me all your money. So we've got our function here, this squiggly line, and we want to find the average rate of change of whatever this is. We want to find the rate between x equals a, this point here, and x equals b, this point here. Now the corresponding y value at x equals a is f of a. We plug our a value into our function and we'll get that point there. Same over here, we plug our b value into our function, we'll get that point there. So we've got two coordinates now. We've got the coordinates of point A. Point A is going to be a f of a, the x coordinate and the y coordinate. B, well, that point is going to be point B, and point F of B. Again, X coordinate, Y coordinate. So then we just get the slope between those 2 points. And those of you who have done vectors or have done slopes before, it's still just the Y step over the X step. The Y step is FB take FA. X step is B take A. And you plug it in your equation right here. So this is your slope equation, delta Y on delta X. And that will get you the average rate of change between those 2 points. This is the gradient, what we call the gradient of the chord AB. You just have to know it as the average rate of change between those 2 points. Okay, as an example, we're going to look at this one here. You may want to draw down this example here. And I'll talk you through it in just a minute. So once you've written this green box down, we're going to write this example down and we're going to go through it. You finished yet? Right now. Fantastic. So if we want to know the average rate of change between 0 minutes and 2 minutes, well, what we need to do is we need to find the X and Y values at those points. So first of all, let's start with this point here, point A, and we're going to call that point B here at 2 minutes. Point A will be 0 for the X and 5 for the Y. Point B is going to be 2 for the X, and we can just read this straight off the graph here, 20 for Y. What we can then do is we can get the gradient or the slope of the line between A and B, and that is the Y step, 20 take away 5, divided by the X step, 2 take 0. 20 take 5 divided by 2 take 0 will give us 7.5 degrees Celsius per minute. Again, notice the units here, notice the rate, degrees Celsius per minute. That means that every single minute, our temperature is increasing on average 7.5 degrees Celsius. So, and that's just between 0 minutes and 2 minutes. So we could say on average it's increasing about 7.5 degrees Celsius per minute. Obviously it's not exactly, but it's pretty close. And that's the whole point, is that this is an estimation, it's an approximation. We'll talk about how to do this exactly later on in this course. So that's it for this video, ladies and gentlemen. Give these questions down here a go, and remember, never forget, extremely important, whatever you do, stay classy.